In this video, we're going to do a QQT FRQ for AP Physics 1. We have three small cubes, A, B, and C, are released from rest at the bottom of a tank of a density. All cubes have the same volume, and the densities of the cube are going to be these densities respectively, where they are ranked A is larger than B, is larger than C, is larger than the density of the liquid that they're inside of. So we want to know which of the forces is going to be the largest. Well, the largest is going to be FA, and the reason is because all of them are going to have the same volume because they're in the same liquid, so they all get the same FB. However, cube A has the greatest density, so that means that cube A has the greatest weight. Since the bottom of the tank must support the cube, the heaviest cube is going to need the largest normal force from the bottom. Now, starting from Newton's second law, derive the general expression for the normal force that the tank exerts on a cube of a volume V initial and density 1 as it rests at the bottom of the tank with density of the liquid. Now, let's list all the forces that are on the cube. Well, when we have a cube like this, it's going to be at rest. So acceleration will equal to 0. You're going to have a downward force of gravity, an upward force on the cube. Using Archimedes, you have a normal force on the cube acting up on the point of contact, which is going to be on the ground, Fn. This is the floor. Now we can use Newton's second law. We only have vertical forces. And let's make our upward direction as positive. So since we have our cube at rest, we can say that we have AY equal to 0. So this is equal to 0. Solve for normal. Mass is equal to density 1, V. So that means that weight is mg. So Fg is going to be times g. Now, we know that we have to substitute in our buoyant force. So we know that if the cube is fully submerged, then the displaced is equal to this. So we know that you have the buoyant force is equal to the weight of the displaced fluid, and that's going to equal to this expression here. So then our final expression, Fn, we have this. And you can rewrite this like this. Now, for our next part, justify the expression for the normal force you derived in part B is not consistent with the claim we made in part A. So we know that we found this expression. So let's think about all our cubes. We have V initial, this, and also this. They're all going to be the same. Our only change is this. So we were already given this ranking. Therefore, we know this. Therefore, we know this. So that's our greatest.